Section 8.2 is about properties of parallelograms. So a lot of what we're going to be doing this chapter has to do with special types of parallelograms or other quadrilaterals. For our warm-up, we are asked to find the value of x. What type of polygon do we have on number 1? A quadrilateral, because there are 4 sides. All the angles inside any quadrilateral should add up to what? 360. If you didn't have that memorized, what formula would help you figure that out? N minus 2 times 180. But either way, you should know that all of these angles add up to 360. So if we add 82 plus 120 plus 98, what do we get? 300? So x plus 300 equals 360. I just went ahead and added those up before I wrote that down. To get x alone, we would need to subtract x equals 60. All right, to find the coordinates of the midpoint, how do we find a midpoint? Not x plus y. Okay. Some people seem to have a general idea. Most people seem to know that we have to divide by 2 at some point. We're going to add the x's together, divide by 2. Add the y's together, divide by 2. So to find the midpoint, if we add the x's together, negative 2 plus 10, divide by 2. And then add the y's together, 6 plus 4, divide by 2. Negative 2 plus 10 would be what? 8 divided by 2 is 4, comma, 6 plus 4, divide by 2. So that would be our midpoint, 4, comma, 5. When we find the distance between A and B, is what that says over there. It's a little hard to see. To find the distance, what do we use? Distance formula. So distance formula tells me that I'm taking the square root of x minus x squared. So negative 2 minus 10 squared. Plus y minus y squared. 6 minus 4 squared. If we take negative 2 minus 10, what do we get? Negative 12. If we square negative 12, what do we get? 144. Plus 6 minus 4 squared. Add those together. 148. Okay, we could get a decimal approximation, or we could just see if that radical simplifies. Did anybody get a simplified radical for that? 2 root 37. Anybody agree? Seems reasonable. Yes, ma'am. Yeah, we would have to round it if we were to do the decimal. What do we get as a decimal approximation to the nearest tenth? 12.2. Questions, concerns? Need more time? Okay. We're going to go through this and fill out all the notes, and then we can go back through and talk about the examples. So we're maybe going to jump around a little bit. For now, we're going in order. A parallelogram is a quadrilateral where both pairs of opposite sides are parallel. Opposite sides are parallel. So parallelogram ABCD can be written. We draw a little parallelogram to the best of our ability. ABCD. Okay, so the symbol for parallelogram is a small parallelogram. Based on the diagram that they gave us, how do we know that opposite sides are parallel? The little triangles they put on them. So AB and DC each have one little triangle. BC and AD both have two little triangles. Those are the markings that we use for parallel. Need more time? Moving on. First theorem, if a quadrilateral is a parallelogram, then opposite sides are congruent. Which means that AB is congruent to CD. It also means that BC is congruent to AD. Now remember, those little triangles they put on there only tell us that they are parallel. So if we wanted to show that they were also congruent, what would we need to put on our diagram? The little tick marks, the little dash lines. So those could each get 1. These ones would get 2. So far, so good? Okay, just because they're parallel doesn't make them congruent. It's the fact that it's a parallelogram that makes them congruent. Remember, we could have parallel lines that are not congruent, like this. Right, just because they're parallel doesn't make them congruent. All right, the other theorem on this slide. If a quadrilateral is a parallelogram, then opposite angles are congruent. So, for example, angle A would be congruent to which other angle? C, the one that's opposite it or across from it. That would also mean that angle B is congruent to angle D. And again, you could mark this in the diagram with the arcs. A and C could each get 1 arc. B and D could each get 2 arcs. Questions, concerns? For sure. Need more time? Okay. We'll go ahead and just do this example real quick. This one shouldn't take too long. If we're finding the values of x and y, which one's easy to know right away? Y. What is y? Okay, we know y is 68 because this is a parallelogram. They marked opposite sides parallel. So because it's a parallelogram, opposite angles are congruent, so y is equal to 68. We all okay with that logic? How are we going to find x? Set x equal to 13? Okay, good. We set those sides, opposite sides, equal to each other. So x plus 6 is equal to 13, which makes x equal to 7. Questions, concerns? Now, just as a question, does this also mean that GH has a length of 13? No. Okay, GH would be congruent to FJ, but not necessarily to FG or JH. Later on in this chapter, we'll talk about when that does happen, but not today. Another theorem about quadrilaterals, if they're parallelograms, consecutive angles are supplementary. What does that mean? Add up to 180. Supplementary. Okay, so in this case, if I were to take x plus y That would add up to 180 degrees. Notice that it's any pair of consecutive angles. So if I were to talk about angle A, consecutive to angle A would be either B or D. So it's either pair of consecutive angles. Questions, concerns? Okay, we'll keep it moving. The measure of one interior angle of a parallelogram is 30 degrees more than the measure of another angle. Find the measure of each angle. Now, if you wanted to draw yourself a diagram, you could. That would be fine. You don't necessarily need one. So, what do we know about these two angles right away if they're in a parallelogram? They're supplementary. Okay, we know that some angles are congruent, but they're telling us that these angles are different. One of them's 30 degrees more than the other. So these ones are not going to be the ones that are congruent. Does that make sense? They're telling us these two angles are different. So these two angles have to be consecutive to each other, meaning they add up to 180. If you don't know something in a high school math class, what do you usually assign it? A variable like x. So if the first angle is x and the other angle is 30 degrees more than that one, how could we represent that angle? X plus 30. And if these two angles are supplementary, what are we going to do to them? Add them together and set them equal to 180. We have questions about this thought process. If a diagram helps you, you could draw yourself a little parallelogram. You could say, well, if I know this one's x degrees, this one has to be x plus 30 degrees, and you could show it in a diagram. But you don't have to do that. To solve this, we would combine like terms and get 2x plus 30 equals 180. To continue solving this, what should I do? Subtract 30, 2x equals 150. Then we would x equals, are we done? Not quite. What did the question ask for? Find the measure of each angle. How many did we find? One of them. The other one would be, what would it be? 105. We add 30 to that, we get 105. Okay, so we would have two angles that measure 75 degrees. The other two angles would measure 105 degrees. Of course, a quick way you could check to make sure this is reasonable is to realize that these two angles add up to 180, so that's good. They better do that inside a parallelogram. Questions, concerns, or need more time with that one? Okay. Keeping it going. I'll give you a minute to try this one on your own before we talk about it. Solving for x and y. All right, in order to find x, what equation did we set up? Kobe? Okay. The way you did it sounds valid, but it doesn't sound like the quickest way. Did anybody do it maybe a more direct path? Adriana? We're talking about x right now. want Caleb to give it a try?
I did 180 minus 72, which is 108, and then I took 108 and equaled it to x plus 30, and I got 78.
Okay. So, another way of writing it, Caleb just talked through some of the steps. If we add those two angles together, they should equal 180, which is why Caleb said he just subtracted the 72 right away, and that's fine. Okay, these two angles should be supplementary. They are consecutive inside of a parallelogram. So to me, this would be the most direct path to getting your answer. Okay, you could subtract them one at a time, which sounds like that's what Caleb did to an extent. Or you could add these together and then subtract from 180. Either way, 78. Caleb, that's what you said you got?
Yeah.
Okay, good. I would agree. Questions, concerns about that? Kobe, is that what you got as well? Oh, okay. So the way Kobe was talking through it was to talk about all the angles inside of that quadrilateral, which would be fine. Okay, we would know that opposite angles would be the same. So it's reasonable to start with 360, subtract off the two that you know, which would be those 272s. But then you would have to take x plus 30 plus another x plus 30 and set it equal to whatever you got. That way would work. It's just longer. So there's a higher likelihood of making a mistake somewhere along the way. Anybody have questions about finding x? All right, Deidreana, did you have the equation for y? That sounds a little big to me. Brianna, what equation did you set up?
8y minus 3 equals 25.
Okay, so I would agree that this would be an appropriate setup for finding y. What do we know about the sides, opposite sides of a parallelogram? They're congruent or they're equal to each other. So if 8y minus 3 is on the right side and 25 is on the left side, those should be congruent to each other because it's a parallelogram. Questions about that equation? Okay, to solve that, we would need to add 3 and then divide by 8. Let's see, those are both divisible by 4. So you could say 7 halves, or as a decimal, 3.5. I would accept either way. Questions, concerns? Okay, I'm not okay with you leaving it as 28 over 8. You would need to either give me the exact decimal or give it to me as a reduced fraction. Questions, concerns about example 3? All right, we'll move on. We've got yet another theorem about parallelograms. If a quadrilateral is a parallelogram, then its diagonals bisect each other. What does it mean to bisect? Kira? Okay, splits it down the middle, splits it in half, creates two congruent pieces, something along those lines. So this doesn't mean that the diagonals themselves are related to each other. However, it does mean that BM would be congruent to what? MD. Okay, so this diagonal is split into two congruent pieces. It would also mean that AM is congruent to MC. So the other diagonal is split into two little congruent pieces. This does not mean that BM and AM are the same. That's not necessarily going to be true. We will talk about specific situations when that does happen later on this chapter. Questions, concerns, need more time with this theorem? Warm, fuzzy feelings all around? Okay. Given that this quadrilateral is a parallelogram, find MH and FH. Before we can find MH and FH, what do you think we need to solve for? X. We need to solve for X. Once we know X, we can plug it in and find these segments. What equation could we set up to solve for X? X plus 10 equals what? Okay, very good. So we were told that this is a parallelogram, which means the diagonals bisect each other. So those two pieces are equal. In order to solve for X, what should we do? Subtract what? Okay, I agree. Subtracting X on both sides is probably the best way to go. And then we would divide. We get X equals 2. Now, again, this does not mean that we are done. They asked us to find MH. What would MH equal? How'd you get 12? Good. 6 times 2 gives us 12. What about FH? How'd you come up with 24? Okay, so we would have two pieces that are the same. So you could either take 12 plus another 12, or you could take 12 times 2. Either way, we would get 24. Questions about MH or FH? Okay, my other geometry class has already done this whole chapter on parallelograms. So one of the biggest issues I noticed when they would do worksheets is they would not pay attention to what they were being asked for. So make sure you know, are you being asked for part of a diagonal or the whole entire thing? Or are you given part of a diagonal or the whole entire thing? Because it makes a difference how the problem goes. Questions, concerns? On we go. Parallelogram STUV has the vertices 0, 0, 1.55, 6.5, 4.5, 0. The diagonals intersect at point W. Find the coordinates of point W. Graph paper might be a little helpful for this, but I don't think it's entirely necessary. We could just draw out a parallelogram. It's probably not going to be drawn to scale, and that's fine. It's probably close enough. Okay, you could imagine that you have some axes, like your y-axis and your x-axis drawn in. So they have point S at the origin. So S is at 0, 0. Okay, V is also going to be on the x-axis, so we might as well put that one over there. V. How did I know that was on the x-axis? Okay, the y-coordinate was 0, so I knew that one had to go straight over there. T is up here at approximately 1.5, 5. And U is over here at 6, 5. So if you had actual graph paper and you really wanted to be precise about plotting them, that's fine. However, I think a rough sketch is okay for this. It'll satisfy what we need it for. We're told that the diagonals intersect at point W. So it might help if I draw in those diagonals. We got this point here, W. So if the diagonals bisect each other, then we could call W the what of either diagonal? The midpoint. That's why that was in our warm-ups. W is the midpoint of both of our diagonals. We all understanding that? Okay, because these get bisected both ways. So you get to choose which coordinates you're going to use to help you find that midpoint. In my opinion, there is one option that's a little easier than the other. So which 2 points do you think I would choose if I'm finding it, Detriana? So which 2 points that we were already given? I think you're on the right track. Okay, S and U. So I think it would be easier to use 0, 0 and 6, 5. First of all, 0, 0 is always easy to use. Also, we don't have any decimals to worry about. That's not to say you couldn't do it with the other 2 points, but I think it's easier. So we're finding midpoint. That means we're taking x plus x over 2, and we're taking y plus y over 2. All right, so 6 plus 0 is divided by 2. 5 plus 0 over 2. 2.5. So that would be our coordinates of point W. Questions, concerns about finding those coordinates? We're sure? Warm, fuzzy feelings all around? Okay. Your homework should be on your assignment guide. It's also up here. We've got plenty of time to work on either our homework or our project, because our project is due on
Wednesday.
Friday.
Oh, Friday.
If you have it done Wednesday, that's all the better. Also, we've got a quiz coming up this week. We are going to push our quiz to Friday, since several of you will be out on Thursday. Okay. We will have an in-class assignment. So those of you that are going to be gone will be responsible for getting that made up.